Good morning, students. Today I will explain you conservation of energy. Simply we say conservation of energy means energy can neither be created nor it be destroyed. It changes only from one form to the other form. That is, energy cannot be created, cannot be destroyed. You see, in our universe, different types of the energies are there. In our universe, different type of the energies are there, but the total sum of all the energy remain constant. Total sum of all the energies remain constant. That is, we say that the energy cannot be created and cannot be destroyed. Suppose there is a stone lying as such and it has some potential energy. When it is thrown for some distance, then during the motion some of the potential energy changes to the kinetic energy. Suppose here half of the potential energy changes to the half of the kinetic energy, then again at a given point sum of both, that is kinetic plus potential, remain constant. So mechanical energy, that is kinetic energy, and the potential energy, that is a constant value. So we say that energy cannot be created, cannot be destroyed. It can change into the different forms. For example, when electrical energy is passed in a bulb, it gives the light, but some of the energy is lost during the heat. So here energy, electric energy converted to light energy, that is energy is transferred from one form to other form, and the energy remains constant in the universe. Now we have to prove that kinetic energy plus potential energy is a constant. Suppose a body of mass m at A. It is above the ground at a height of h. It falls from this A to C on the ground. We take 3 points A in between A and C, B and C. At the 3 points, we will determine the energy. Now at point A, at a certain height, here potential energy is mgh, h is the height, g is the gravitational force, m is the mass, and kinetic energy is g. So sum of the energy at A is mgh. Now when this object falls from A to B, it covers a distance of x. Now at B, when the object falls to x distance, where v is the velocity, initial velocity is 0 and distance is x. So from the third law of the motion, v square is equal to u square plus 2as. Here u is 0, so v square is equal to 2as. Now kinetic energy is equal to 1 upon 2 mv square. So v square is 2as, 2 is divided out, that kinetic energy becomes mgx. Now at B, the potential energy, that distance will be h minus x from C. So potential energy mg into distance h minus x. So the total energy becomes mgx plus mgh minus x, and we taken common, x divided out, that the total energy becomes mgh. So at B point, the total energy becomes mgh. Now when A reaches to the ground at C, here initial velocity 0, s is the total height, and acceleration is g. So from the third equation, v square is equal to u square plus 2ah. So u is 0, then v square is equal to a 2ah. Now putting the value of v square in 1 upon 2 mv square, we get 1 upon 2 m 2ah. 2 to divide it out, a is g, then the kinetic energy become mgh. Now at the ground, u0, height is 0, so the potential energy is 0. So the total energy is kinetic energy plus potential energy, that is mgh plus 0 is equal to mgh. So from this experiment we say that the total energy remain constant in the form of the mgh as the height decreases. So at A it was mgh, at B it was again mgh, and at C it was again mgh. The point is that as the height decreases, potential energy is converted into the kinetic energy. At the ground, whole of the potential energy is converted to kinetic energy. Here one point is very important. You see, when something falls on the ground, here we are dealing only the energy, that is potential to kinetic. But what happens when something forms on the ground? When an object is stacked on the ground, energy changes, but some other undesired energies are also found. That is, when it stacks, it may convert into the heat energy, or it may come to some sound energy. So we say there is a loss of the energy, that is known as the dissipation energy. So here we are not considering the dissipation energy because that loss goes to the atmosphere or in the universe. So here at the three different stages we prove that total energy remains constant. So this is conservation of energy. That energy means it can neither be created nor it be destroyed. It changes only from one form to the other form. So I think it is clear to you. So total energy remains constant. So please, if you like my videos, please share it and subscribe. Thanks very much.